Hello everybody, I will start my today another live coding session. So today I solve this question, searching rotated sorted array. So in this question, there is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly left rotated at unknown index k, such that the resulting array is nums k to nums n-1, the last element originally, and then num 0, the first element originally, and then nums k-1 before the pivot. Element before the pivot, yeah. They're indexed. For example, 0, 1, 2, 4, 5, 6, 7 might be left rotated by 3 indices and become 4, 5, 6, 7, and then 0, 1, 2. So it says possibly, so nums may not be rotated. So maybe originally it is 0, 1, 2, and after rotation, it should be 0, 1, 2. It can be 0, 1, 2. Yeah. And giving an array nums after the possible rotation and an integer target returns the index of the target if it is in nums, or -1 if it is not in nums. You must write an algorithm with overlog n runtime complexity. Okay, so let me clarify my understanding first. So in this question, I'm giving an integer array nums, and also I will be given the target, which is yeah, integer, yeah. And I will return the index or -1 if the target doesn't exist in the array nums. Okay, so for the constraint, so I can see from here, nums has at least one element in this way. Yep, aside from that, everything is fine. Oh, and also there was saying that the nums have distinct values. Yeah. Okay, that being said, I will take a look at examples. So let's say I originally have array like this. And let's say I pivot this at index 2. So it becomes like this. And then let's say, let me pivot at 5. I mean, number 7. Let's say I'm looking for, say, 9 or maybe 10 or maybe 3 or maybe 4. So in this case, this should return index 1, obviously. And here, this should return index -1. And here, this should return index 0, 1, 2, 3, 4, 5. And here, this should return -1. Yep. So I somehow find this index, return index in log n time. Yeah. Okay, so let's say I'm looking for 9. So in this case, oh, and also, yeah, it's okay. Because 9 is larger than 7, it should be in the first half before pivot. Yep. But for 3 and 4, because this is smaller than 7, it should be in the latter half. Okay. And that being said, if I'm looking for the number which is larger than num 0, what I should do is basically I look for the number which is larger than 9, larger than target or smaller than num0. Larger than some index which meets um, larger than or equal to target or nums something is smaller than the num0. So when I think of this, what happens is that because target is now 9 or 10, let's say if each element meets this. So this doesn't meet, index 0 doesn't meet the, you know, requirement. Wait a minute, target purchase or yeah. Okay. So this isn't true, but this is true. True, true. And here, this is true because num's index, here, the number 1 is smaller than num0, which is 7. True, true. So, and now we can say, find the first true index and see num's sub index is equal to target. Yep. So basically with this equation, I said if each element meets this equation or not, and I will find the first true, yeah, out of these, yeah, numbers, elements. And this is completely possible to do with binary search. Yeah, because this is what I'm looking for is the first true, which is switching from false to true. Okay. So next example. So looking for 3 or 4, which means that the number I'm looking for is smaller than the first number. So in that case, when I'm looking for 3 or 4, this should be the first one to me. I will think of the equation, which I can meet this. Yeah. So I can say I'm looking for the number which is larger than the target. No, smaller than the target, but larger than, this and this. But, sorry. Number which is larger than or equal to target, but smaller than num0. Yep. So in this way, each element is satisfies or dissatisfies this condition. So the boolean should be false, 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 and it's true, true. And what I have to do is find the first index. Yep. First true index and check that index number as that index is equal to target. If it's true, I return this I, otherwise I return -1. Okay. So that being said, the time complexity should be O of n, assuming that there are n elements in the given array. Because every time I do the binary search, low and high, and every time I take the meter index, according to the result of that meter index, I can move the low index or high index to there, and I can narrow down the scope by half. It goes half by half, so it takes O of log n time. For space complexity, this should be O of 1, constant, because I don't need any extra space. Okay, this is it. That being said, let me start the implementation. So I start low and high from here, and while low is more than high, I do this. And I would say, so I define the function like condition. So let me write it first without the function. So if the target is smaller than num0, yeah, so I think I should put two methods here. And for finding latter half, and what I can do is if the target is larger than or equal to this, I should find it from the first half. Otherwise, I find from the latter half. Okay. And here, I can say this. And here, I can say this. Okay. And here, low is 0, high is this. And because I'm looking for the target from the first half, this is the case of this. I use this condition. Oh. So if this middle index number is larger than or equal to target, or if it is smaller than 0, sorry, if it is smaller than the first element, it's around this area. So first true can be current middle or before. Like this. So let me see. This is true. Yeah, this one or before. But if this is false, the first true is greater than the current middle index. It should be like this. Okay. And in the end, I check if this row index is equal to target, row index number is equal to target, and if it is true, I return row. Otherwise, I return -1. Basically like this. And for the finding latter half implementation, I can almost use this. Sorry. Yeah, the number I'm looking for is smaller than num0, the first number. So I have to check this condition. So if this is met, the current meter index is between these truths. So the first true is that index or before. High is middle. Yeah, the same. Otherwise, I'm around here. So low should be middle plus 1. Yeah, because true is greater than the current false index. Okay, and this is it. Okay, so the only difference is the condition, but I separate them into two methods, helper methods, so that I can think of it easily. Yeah. Okay, now let me try run my code. So I'd like to check the case, something like this. I mean, no pivot. Let's do this. So I expect this to return 1. And also there is a case that there is a pivot. I mean rotation. Let me do it like this. And the target is 4. Which should return 1. Or target is 2, which should return 3. Okay. So now that being said, so for this case, because target is 2, in line 50, this is true. So I go to line 55, and num0 is, target is larger than the num0, so this is true. So now low and high is 0 and 2. Yep. And then middle should come here first. Then, because num's middle is larger than target, yes, so high is equal to middle. So high comes here. Yeah. Then I come to line 62 and go to line 63, and middle is now 0 plus 1 divided by 2 is 0. The middle is here. So num's middle 1 is not larger than target, and the latter half, num's middle, which is 1, is not smaller than num0. So I go to line 69, and low is middle plus 1. So low and high is now here. Now, as that row is equal to high, and I return, because num0 is equal to 2, which is the target, so I return low, which is index 1. I pass this test case. Yeah. Oh, by the way, I think I also have to check the case if the number is not included. So, yeah. Like this. Maybe this. But anyway, by this first case, I could cover actually finding first. So let me check finding router. So I will check this test case. The low and high begins from here in line 82. So here, Wait, where's middle here? Hmm? Oh, no. This should be high is larger than low. Yeah. In this case, middle should be 0 plus 3 divided by 2 is 2. So middle should be here. And then num's middle, which is 1, and target is 2. So the first half is not true. For the latter half, num's middle, which is 1, is smaller than num's middle, so num 0, which is 3. The latter half is 2. How is equal to middle? Wait. Wait a minute. So target is 2. And num's middle, which is 1, is smaller than num's. Yes, this is true. Wait. The equation should be this. But this equation is same as this equation is the same as this, which is wrong. I should put this one here. So now I can say target is 2, num's middle is 1, and num 0 is 3. So this is not true. So I go to line 98, and row is middle plus 1. Now it's here. So now I can say row is equal to high. I go out of the while loop and go to line 102, and num's row is 2, which is equal to the target. I return low, which is index 3. Okay, so I passed this test case. So basically, that being said, I could cover both methods. So I'm pretty confident in my code. So let me submit. Self.oh, I don't need self. Here. Good. Okay, now accepted. So let me quickly wrap up. So today I solved the question, searching rotated sorted array. So I'm given the integer array nums, and this is originally the sorted strictly ascending array, which has unique values, distinct values. But before giving this nums array into the function, this nums array is rotated. So picking up the pivot index, there was the rotation on this nums array. And I'm given this nums array, and my task is to find the index, which meets, which is equal to the target. And if target doesn't exist in the given array, I return -1. So the approach I took is to use the binary search, especially the find the first true pattern. Yeah. And to use this find the first true pattern, I firstly thought of the two cases, whether the target number is in the first half, or the target number is in the latter half. So I did the binary search for each of these cases. Yeah. And basically I thought of the equation so that I can use the template of the binary search, find the first true. Okay, so that being said, I finished my today's coding practice. Thank you so much. Bye.